I am feeling a little bit. Could be a little bug. Could be a little bug. All right. So what have we done? We are counting on the abacus. We're counting on the abacus. It's so funny. Um, we're just counting on the abacus. That's all we're doing. We're just looking at the abacus and looking at it. Just that's what we're doing. We're just counting on the abacus. What are we doing? Okay. So we're gonna count. We are gonna count. We're gonna count 1, 2, 3, 4, and then 5. And then 5, we have 6, 7, 8, and then 9. After 9, welcome, welcome, welcome. So, oh, you can't even see it. There you go. There you go. All right. What we're going to do is we're going to be counting on the abacus. This is the abacus. This is a counting tool. This is a math tool. This is different than all the other math tools. This is the greatest thing next to sliced bread. All right. So what we're going to do is we're going to count on the abacus. Counting on the abacus just means that we're looking at this thing. This thing is a counting machine. It's a counting machine. No, it's not a machine. It's just a counting tool. It's a math tool. What are we going to do? What are we going to do? Oh, I'm just rearranging. I'm always rearranging. I got to rearrange because it's always like wonky. Okay, so what we're going to do is we're going to count. 1, 2, 3. That's 4. This is 4. That's not 3. This is 4. This is 4. Why? Because all of the beads are touching this horizontal bar. This horizontal bar is the thing that tracks us. It's the horizontal bar that tracks the beads. The horizontal bar tracks the beads, so when this is 4, this is 5. This top bead is always going to be the value of 5. The value of 5, and then 6, 7, 8, 9. This is how we count on. When we count on, we do 5, 6, 7, 8, 9. And then this is 9 altogether. Now, if you look, this is 9, that's 9, this is 9, that's 9. These are all 9. So every column will have a value of 9 no matter what. Now, if we look at it, we can count 1, 2, 3, 4, but it looks very similar to this, doesn't it? So this is 1. If we look, this is also 1. So all of these are 1s, but it all depends on the place value. So what? What? Abacus does place value too? Yeah, if your kid ever has a problem with place value, set them on an abacus and they'll be able to understand it because this is all about place values. Just like how we write. When we write, we have our ones, tens, hundred, thousands, 10,000s. Just as we see it, we read it. We can read it. See it, read it, own it. I don't know. I don't know what I just said over there. Hey, good morning, good morning, good morning. Welcome, 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 welcome. Let me know if you guys have any questions about this crazy thing. This crazy thing is not really crazy. It's a very old, ancient thing. Tool. Very old, ancient tool that's being used in many, 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 many years. However, nobody knows about it. It's like a great secret. Judith, like my mama. Hey, welcome. Okay. So we're going to count 1, 2, 3, 4, and then 5. Because we have 5, all the top bead has a value of 5. This is 5. These are all 5. These are all counted now. These are all counted. But thank you so much for the heart. But what we're going to do is we're going to look at it. So we have 5. This is 50. 5, 0. This is 500. And then this is 1,000. How do you do the invisible abacus? You got to put this in your head. Joseph in Texas too. That's what you got to do. You got to work with this as long enough to be able to imagine this in your mind. That's what you call the invisible abacus. But thank you so much for the comment. I appreciate that. Now I know I'm not the only one in my life, because nobody else is talking. Nobody else is talking. All right. So what we're going to do is we're going to count 1, 2, 3, 4. Do you have any more questions, Joseph? I'm going to pick on you now because you're the only one talking to me. So we have 4. This is 4. This is 5. If we can imagine these abacus in your mind, then you'll be able to do it in your head. That's why you get all those kids that do this, right? Because they're doing this. But I'm not doing this. Seeing them do the hand motion is amazing. Yeah, but it's also practice too, right? So then when we do it, we want to do 5. When we add the 5, it's always a finger down. 5, and then 5, 5, 5, 5, 5. So it's a little bit of that, and then 1, 1, no, not, sorry, 1, 1, 1, 1, 1. So on this one is only a 7-column abacus. So the 7-column abacus only does so many digits. But if you want to do bigger numbers, the kids might have the 13-column one, and the colors are all the colors doesn't mean anything. It works exactly the same. It's all about the place value, the placement of the beads. So we have the top bead. These are all the top beads. This is the top bead. This is the bottom bead. These are all the bottom beads. These are all the bottom beads. So the colors doesn't matter. I just use the colors because it just looks better, right? So with this one, on the 7-column one, I can only do ones, tens, hundred, thousands, 10,000. I can only do numbers up to 10,000. However, on my 13-column abacus, I can go to trillions. Show me. Okay, so hold please. I gotta get paper. I gotta get paper. Okay. Because I like to write. I like to write. All right, so what is the question? The question is 235 minus 126. Okay, this might be a little bit above the pay grade. Why? Because there's a few things that we need to know. One of the things we need to know is how do we make a 5 and how do we make a 10? There we go. Okay, let's try that. All right, so the first thing we're gonna put on the abacus, right? We have 2, 3, 5, and then what are we gonna do? We're gonna do 1, minus 2, minus 6. Now the thing with minus 6 is that we need to do a formula. Teachers are we're teaching children how to make a 10. We know that when we make a 10, we have a 6 plus 4 is equal to 10. Why is this critical? This is a fundamental element, fundamental equation that the kids need to know. Now this is a fundamental concept, right? How to make a 10. This is very critical. But the thing is we're going to actually utilize this. What we're going to do is we're going to modification. The reason why is, guys, I want my numbers to work for me. So this is what's going to happen. What we need to do is we need to take away the 6. To take away the 6, what we need to do is minus the 6 is equal to minus the 10 plus the 4. This specific thing, this right here, is what we call borrowing in mainstream math. But in Abacus, we just call it minus 10. So Abacus strips away the complexities. So when we minus the 10, all we got to do is take away the 10 and add the 4. That's all we're doing. And this is a fundamental thing. You know this, you can do a lot, if that made sense. But what we just did is we jumped ahead, right? After we learn how to take away a few numbers, we can add a few numbers. And then the next thing we do is we need to understand formulas. After you understand formulas, then you can do anything. Sky's the limit, really. Because there's 4 sets of formulas that you need to know. There's the 10 formula. So if you know how to add a 10 minus the 10, did that make sense, Joseph? I don't know if you're still here. After we add a 10, we minus the 10. And then after we minus the 10, we need to understand how to add the 5 and take away the 5. These are things that need to be known. These are known things. Why? Because this is what makes adding and subtracting funny, incredibly easy. All of this, understanding these 4 items, makes math. Oh, good, you're still here. Good. You know what? Okay, good. Because you're the only one commenting, so I wasn't sure. So knowing these formulas, hands down, you can do any question. You just need to know these formulas. And what are these formulas? These are core concepts. So what are the core concepts? The simplest one I can tell you, right? It's simple for us now because we're adults. But if you look at it, these are things that we need to know. I was doing another one, right? We have 12. If we did 12, notice we don't have enough beads to minus the 12. Well, how are we going to use the beads? Well, we use the beads. We know this formula. This is the formula. How do we get this? Well, if you remember in school, how to make an 8 plus 2 is equal to 10. This 10 just means I'm going to take it from here. It only means that I am. So how do you read ups and downs? Oh, so whatever is this horizontal bar, this horizontal bar is what tracks the beads. So we have 12. 1, 2. And then when we look at it, these are, where's my place values? My place values, right? When we look at the place values, we have ones, tens, hundreds, thousands, 10,000. Just as we write, so this is a place value, right? If we did this, it'd be 9, 2, 1, 5. And that's it. Make sense? So that's what the ups and downs means. It only means that the horizontal bar, this is the horizontal bar, that's what tracks the beads. And it will help us. All it does is just tracks the beads. But what we do in our head, we do all the calculations in our head. We just move the beads. So going back to this one, right? I have 12, take away 8. I have 12, and I take away 8. I know if I take away 8, I have to minus the 10 and then add the 2. So then my answer is 4. This is an easy problem. But to show you how it is easy to work with, then you can make it into bigger problems. Does that make sense? How about the beads on the left to the right of the 5? How about the beads to the right of the 5? Like this one? Or these ones? Oh, this one? This is the decimals. The decimals. So we have our ones, just like how we have money, right? If we have money, what is money? Like $3.25. $3.25. So just like that, it'd be $3.25. Wow, you didn't see that. Sorry. $3.25. It's just a decimal. So anything after the indicator, this is my indicator, this is my dot indicator. This dot indicator tells me it's a ones place. So just as we write, we have our ones, tens, hundred, thousands, 10,000s. We are reminded our money, our tenths, right? This would be 25 cents. If we did 1 penny, that would be a penny. 2 pennies, 3 pennies, 4 pennies, and then a nickel, right? And then this is 10 cents, 25 cents, and then this is 50 cents. Make sense? Yeah. Great. Thanks for the comment. There's only 5 of us, but that's okay. How's it going? I see people here, but people are not commenting. So now I'm just talking to Joseph. Haha, Joseph, you're my only person. You're my friend that I'm talking to right now because I need a conversation. What we do is we understand how to read the abacus. When we understand how to read the abacus, thank you so much for the follow. All right. So what does that mean? It means that we just need to understand how to read the abacus. When we understand how to read the abacus, then we can do adding, subtraction, multiplication, and division. Thank you so much for liking the lives, people. May and YM. If you guys have any questions, let me know. I'm just babbling. I'm just babbling. But yeah, let me know if you have any comments and questions. If you have questions, like why am I starting over here? I'm starting over here because I have this dot indicator. You could start anywhere there's a dot indicator. I like to start at the dot indicator. Why? Because it's easy for my brain. If I do here, then I'm like, oh, was it a 10 or was it a 1? So the difference is if I have more dots, I could choose any one of these. Thank you so much for the likes. So if I choose this one, I usually, if I have a 13 column one, I usually start in the middle. I like to start in the middle because then I have a lot of numbers in the beginning and a lot of numbers in the decimals. It seems easier. Why did school stop teaching this method? I don't think schools ever taught this method, honestly. To tell you the truth. I don't think because who are usually teaching the schools is not people who know this. Not to be, anyways. So, and I think that's what it is. And what I'm trying to do, I'm trying to popularize this. I'm trying to popularize abacus. I'm going to abacify everything. My thing is to make sure everybody knows what abacus is. Can I show division? I can show division, but promise not to get overwhelmed. Because it's a little much. I'm telling you, it is a little much. It is a little much because there's a few things that we need to understand. You're going to you promise not to be overwhelmed? Promise not to throw up your hands like, you know what? This is too complicated. You promise? You have to promise. Yeah? Do you promise not to be overwhelmed? I'm waiting. No joke, no lie. I promise just promise not to be overwhelmed. Thank you so much for the follow. Don't get overwhelmed if I show you how to do division. Because why? Because the one thing we need to do is understand. We need to how to add and subtract first before we know how to multiply and divide. After we know how to multiply and divide, then everything's the world, right? Then you can do whatever on the abacus. Well, not whatever. You could kind of do algebra. You kind of do algebraic formulas. But you can't do calculus or division. You know what? You didn't say it. Don't be overwhelmed. Are you going to be overwhelmed? No, okay, good. Oh, that came late. Pinky probably. Okay, cool. Okay, we're going to do it. Okay, so, sorry, it was, hey, Jasmine Math Tutor, welcome. I'm so happy. Okay, glad to see you. Oh, yeah, thank you. We're going to do these numbers because it's just easier, right? So 3, let me do 2139. This looks easy. This is easy. Why? Because the first thing we're going to do is we're going to understand. What are we going to understand? We're going to understand how to find the place value. Now, the reason why we need to know where we're going to put our answer, we need to understand. So we're going to have a conversation. We're going to have a conversation with our numbers. Now, we have our dividends and our divisor. We have our dividends and our divisors. So we have to count how many digits on our dividend, right? We have 1, 2, 3, 4. We have 4 dividends. Excuse me. And then we have 1 divisor. So 1 take away 4 is equal to 3. That's easy. Now, why do we need to know that? We need to know it because then we know where to put our answer. 1, 2, 3. This is where we're going to put our answer. As we put our answer, I'm going to add my dividend to the abacus. The reason why is because the dividends helps me track my answer. So I'm going to put 2139. Okay, so now what are we going to do? Now we're going to start having a conversation. There's a few things we need to understand. We're going to have a conversation. I'm going to have a little chart. This little chart says, and this is just a chart that I built because I just need to make a comparison. I have to compare my divisor with my dividend. My dividend, I only compare one digit. I don't need to compare anything else. I don't need to compare the whole number. I only compare one digit to one digit. Apples to apples. That's what it is. I compare apples to apples. I don't compare apples to many apples. I only compare one apple to one apple. So my 3 is my divisor, 2 is my dividend. Which one is bigger? Which one is bigger? We know this, right? Hey, Sai, welcome back. So what we're going to do is we're going to do our divisor is bigger. If our divisor is bigger, we know we're going to take 2 digits. That means we're going to take 2 columns. That's all that means. If it's bigger, if the divisor is bigger, I'm going to look at these 2 columns. So the question goes to 3 times what is equal to 21 or less? 3 times 7. So what Abacus does is it breaks it down into manageable chunks. This is easy, right? This is really easy. We know this. I don't talk backwards. I don't say how many times does 3 can 21 divide into 3? I don't think that way. I think more multiplication. So I always say, well, what's my missing factor? And I think that's the thing, right? In school, we teach the kids the missing factor. We don't teach the kids too much about division. So here I do, but I know we're getting into showing what it's like to divide. So I have my answer. My answer is 7. I take away 20 and I take away 1. So now I have left is what? 3 and 9. I have 3 and 9 is left. So what do? I compare again. I compare my 3 and I compare my other 3. My divisor is 3. My dividend is 3. They're the same. What do? I go to the next column over. Again, it's still the same. It's still apples to apples. I compare my 9 to a 0. Pretend there's a 0 here. So 0, right? My 9 is bigger. So if my 9 is bigger, then I'm going to skip one column. I'm sorry, this way. So if the dividend is bigger, if my dividend is bigger, then I have to skip one column. This is a rule. We have to skip one column and then eat one column, like subtract one column. That's what this means. So I'm going to skip this column. I'm going to go over here. Now the question is, I only use one of the columns. So the question is 3 times what is equal to 3? 3 times 1 is equal to 3, so I take away the 3. That's it. And then what are we going to do? We're going to do it again. Our divisor is 3. Our dividend is 9. Our dividend is bigger, so we're only going to use the 1. So the question is 3 times what is equal to 9? 3, because I'm going to skip this column, 3 times 9, 3 times 3 is equal to 9. So I add my 3 and I take away 9. Minus the 9. And that's it. So what is my answer? If you guys can read it, tell me what my answer is. Don't forget, this is my ones, my tens, my hundreds. What do you think, Mally? Mel and Joseph and Untangled. Johnny boy. Untangled. 1, 7. Yes, right? That's what it is. Thank you. 7, 1, 3. That's what it is. Was that easy? That was easy. It's a little complicated, right? It's a little bit. Why? Because we don't have conversations when in mainstream math we don't have conversations with our questions. But in Abacus we actually have a conversation. We have a conversation. We try to make sure we understand what we're doing, because this adds to critical thinking. So does that make sense? So I use this one just because I needed more columns. I can use this one, but it's harder because I don't have enough columns. It's all about the columns. Size matters. Size matters. So that's what the thing. I love math and tutored math. I've never used an abacus. Ooh, really? Heather minus the Doug. Oh, the Doug. Oh, yeah. Well, okay, let's count it. So this is an abacus, this is a counting tool. This counting tool, all we got to do is we need to track our beads. So when we count 1, 2, 3, 4, anytime the beads are touching this horizontal bar, this is the horizontal bar. This horizontal bar tracks us, just like our GPS, just like our phones. You know our phones are tracking us, right? You know, like Siri and all, like Hey Google, they're all tracking us. So let's pretend that this is Hey Google. So because this is tracking us, it's tracking our beats, this is considered 4. 1, 1, 2, 3, 4. That's 5. All the top beat has a value of 5, no matter what. This is 5, 5, 5, 5, 5. These are all 5s. Sorry, I have to drink a lot before my cough kicks in. So, this is 6. 5, 6, 7. I have to stay focused, because if I stay focused, maybe my throat will work. Okay. 5, 6, 7. That's 8, and this is 9. 5, 6, 7, 8, 9. So if you notice, this is 9. This is 9, this is 9, that's 9. These are all 9s. These are 9s. But the difference is, it talks about, the difference is the place value. When we have our place value, we have our 1s, 10s, 100, thousands, 10,000, and that's it. So we are given this place value on the abacus, which is different than all the other abacus that goes horizontal. I don't know how they do place values on that. But on this one, this is a Japanese soroban, abacus, the Japanese abacus. And with the Japanese abacus, we use the columns as place values. With the place values, we have our 1s and 10s and hundreds, thousands, 10,000. So if I do 9, this is 9. This is 90, 9 and a 0. This is 900, and then this is 9,000. Does that make sense? Yeah, right? It's simple. It's simple to use, easy to understand, but it's such a simple tool, but it makes it's so magnificent. It's fantastic. So here is a really drawn out thing. So when we do it, right, it's 9,200. So this is 200, 1, 15, 5 and the 1. So how do you show 10 or 1? Ooh, so 10, so this is 1, right? This is 10, and then this is 100. Oh, sorry, this is 100. 100. So we still pay attention. The reason why is this dot indicator. This indicator tells me where my ones place is. You could choose this one. So then if I choose this one, then my answer here, what's written here would be 0.1. Does that make sense? If I chose this one to be my indicator. But if I chose this one, then it would be 100. Does that make sense? Whew. That was something I was trying to... Okay, so, yeah. So then if we do 6, it's the same thing. This is 600. It's very helpful for the kids to be able to visualize, but also understand how the numbers work, right? You can't go higher than 9, because after 9 is 10, right? Oh, thank you, Matt. Hey, thank you, Jasmine. Yeah, right? So then if we do 11, 12, 13, then I don't know, what ages do you tutor, Jasmine? I mean, I don't know if you want to add this into your little tool belt, but it's really interesting, like how to get them to understand. Because after they do this, right? After they understand, and oh, and Heather does it too. Oh, okay. Maybe it's better for remedial, but I'm not sure. Heather also tutors as well, don't you? Oh, hey. I'm missing. Hey, Ethan! Welcome back! I have tutored. Oh. I'm just looking at my the comments. I didn't realize a bunch of... Oh, hey! Hey, you have an uncle with a lot of Japanese abacus? That's funny. I definitely want to learn the abacus. Yeah. Okay, cool. So the first thing we're going to do, wow. So Ethan, what kind of abacus does no, surplus. Oh, okay. What kind of yes, the Japanese one. So there's two sets, but this is the Japanese abacus. Okay. So the first thing we're gonna do is we're gonna understand how to move the beads. When we move the beads, right? Heather, what ages are your people you tutor or have tutored math? But I've never used the abacus. Yeah. Which ones have you tutored? Like the ages? Because I'm trying to focus on preschoolers to like younger grades. The reason why is because I think it's just easier. It's easier to talk to the kids. But I also realize that there's a gap in the abacus world. There's a gap, and I'm trying to fill it. And so I actually started creating like these worksheets to get the kids to understand how to use the abacus. And so what I did was I just abacify everything. I'm abacifying everything. And then here is all the way to statistics. Okay, I'll have to keep that. My uncle's not sure what kind of abacus. He'll search the past and the surplus. Oh, way! That's cool. Yeah, the one thing I want to know, Ethan, is how many columns and what kind of how many beads. Those would be the two critical ones. I don't know statistics, Heather, but fifth grade, the interesting thing is abacus goes all the way to fifth grade because we can do division on it. So we do division, multiplication, we can do obviously adding and subtracting, but really what it is just we do the calculations in our head and we have the abacus shows me what the numbers are. So what I've done was I've created like all these worksheets to be able to get the kids to be interested in math. And so that's what I'm trying to do. So that's what I have. So the first thing we're going to do is we're going to understand what do we need to do? Well, we need to focus on the add in and not the result. So I'm not sure if you guys remember when you guys were young or when you were going through it. We were always focused on what isn't statistics percentage? I guess, but I don't know the theories of statistics. So I'm not going to go there. So the first thing we're going to do is we're going to understand that we need to focus on the add-in and not the result. So I know in school we're always like, you got to know how to make an 8. It's like, whoa, hold them horses. Why? Because it's different. When we look at the abacus, we have 6, right? And this is going to be easy for now, but we can get like, we always have to build a foundation. We have to build on top of each other, right? So we have 6 and we add the 2. We notice we just need to add these 2 beads. That's all we need to do. It's a simple thing. It's a simple movement and it's not going to be difficult. There are some abacus that's a little bit difficult to move and those would be called the Kramer abacus and that's used for people who have visual impairments. The reason why they want it to be difficult because the abacus is really easy to move. So then you lose your answer. So depending on what kind of abacus you have, it just depends on what you're trying to do. Abacus just means moving beads. That's all that means. So we have 6 and we add the 2. That's it. When we do this question, we don't memorize our doubles. We don't memorize doubles because doubles is only addition. We need to understand how to do subtraction as well. But the first thing we're going to do is we're going to add the 2 and then we add another 2. That's it. Make sense? So when we are looking at it, we're just looking at our beads. So let's say I want to add 5. All I got to do is just add the 5 and there I go. I have 9. When I look at it, I broke up the workbook into add-ins. So when we look at it, we have this one is 5. So I'm going to add the 5 and then I'm going to plus the 3 and I add the 3. My answer is 9. Oh, I'm sorry, my answer is 8, not 9. My answer is 8. Hey, Cheryl's little sister. So what happens when there's not enough beads? Well, that's when we have to start talking about formulas. We are taught formulas. What do we need? What? No, yeah. Well, what we are teaching children now, and I'm not sure if this is what you guys are, I don't know if this is what you remember when you guys were young. But I was never taught how to make a 5. That's how old I am. We were taught to memorize, and memorizing was the greatest. No, memorize is not good, obviously. But what happened is right now we're teaching the children how to make a 5. We know that 4 plus 1 is equal to 5. We know this, right? We also know what? We also know that 1 plus 4, we do the opposite, right? We do 1 plus 4 is equal to 5. And then we do the other ones, which is 3 plus 2 is equal to 5. These are very elementary. Why are you teaching us this? Why are you telling us this, that what we already know? Well, I'm showing this to you because I want to show you that these will work for you. Woo! Welcome, everybody. Welcome. So what I'm doing is I'm just talking about the fundamentals, right? We're just understanding how to make a 5. Well, I want my numbers to work for me. I want my numbers to work for me. We can't just have them sit around and be lazy bums. We got to make them work. How to make them work? We're going to isolate the variable. What does that mean? We're going to, let's say we take a 4. The question is 4 plus 4, right? Let me do that. So the question is 4 plus 4, or we do 3 plus 4. It's okay. We can do one of the two. It doesn't matter. So we do 4 plus 4, right? We do 4. Let's do 4 plus 4. We don't memorize our doubles. Remember that. Don't memorize doubles. So we do 4 plus 4. So what's going to happen is I want to add the 4. There's not enough beats to add the 4. I add the 4, and I add another 4. I can't. There's not enough beats. So what do? Well, this is where we have to know how to utilize our formulas, our concepts, our concepts. So when we isolate the variable, we're going to move this to the other side. This is now a little bit about algebra. So we introduced algebra in Abacus. What does that mean? So when we move it over, it's 4 is equal to 5. No, that's not balanced. We need to balance this equation. So we need to minus the 1. Well, how does that work on the Abacus? If you notice, all I have to do is add the 5 and take away the 1. And there's my 8. That's it. But that's a formula. That's a concrete concept that we can use everywhere. Why? Because let's take it another step further. Let's do 3. Let's do 3 plus 4. I don't memorize doubles. I memorize my formula. Good morning, Audrey. If anybody needs algebra help, Audrey's in the... Go ahead and follow Audrey. If you need algebra, I don't do algebra. I do gateway to algebra. This is cool, right, Jasmine? Yeah, mind-blowing. But again, we don't memorize doubles. So let's do 3. When we do 3, we build, we remember our concept. We don't do the one and done strategies. We do, oh, you know Jasmine too? Okay, so we do this. We add the 5 and we take away the 1 because I'm adding the 4. That's it. That's all I'm doing. I know this. Now I'm just going to repeat it and practice it till it's ingrained into my head. I'm going to repeat it and practice it until it goes to long-term memory. I'm going to repeat it and practice it because what they say, practice makes perfect. Practice makes it what it is, right? So we don't need to do like the strategies that we have. We're being taught different strategies, but we have so many strategies, but we need just to go back down to the basics. Ha ha, you guys are funny. Okay, so let's do another one. Right? It's like a little reunion. I feel like I'm in the in crowd when all the math people comes over because I was never part of the in crowd. I was always a little like random child in the middle of somewhere. All right. So here's the thing. Let's do 2. When we do 2, right? The next thing is we're going to add the 4. We need to add the 4. We don't have enough beats to add the 4. See that? We don't have enough beats to add the 4. What am I going to do? What am I going to do? I'm going to run around with like my head cut off. No, we're not. Why? Because we know this concept. We know how to plus the 5, take away the 1. That's it. Plus the 5, take away the 1. Blue! Welcome to the cool table. Yeah, right, Audrey? Oh my God. I do feel cool. I do. Joseph in Texas, does that make sense? I'm not sure if that made sense. Does that make sense? I mean, what it is I'm not talking about strategies. I'm talking about concrete concepts. I'm talking about concepts. Jasmine, the tutor. Yeah. Yeah. JJ! Right, JJ? Easy, right? Simple to use, easy to understand. Okay. I'm starting to get it. Hey, Micah! Yes. See, the thing is, okay, let's take it one step. Well, what's the one step? Look at this one. This one is not so much. You know what? Let's look at another one. It's the same thing. Let's do 3. We're going to isolate the variable. We're going to do 3. What is 3? 3 equals 5 minus 2. Same thing. Hey, Alexandra. Good. So we're going to do 3 minus 2. Same thing. What happened? But see, the thing is these questions are simple, but we're never taught this. We were taught to do memorize. I don't know what we were taught. I was taught to memorize. That's how old I am. But you guys are learning like different things. So here we do 3. This is the question. 4. And notice I don't have enough beads to add the 3. Well, how do I add the 3? This is the same concept. We're building, right? We understand if we can use the 5 for the 4, we can use the 3, use the 5. Plus the 5, take away the 2. And my answer is, what's my answer? Right? Makes sense. But see, okay, so let's read the abacus. This is the top bead. This is 5. This is 6. This is 7. When I look at it, they're touching the horizontal bar. When it touches the horizontal bar, these beads are counted. If I do this, this is 77. This is 7. 5, 6, 7. The top bead always has a value of 5. The top bead always has a value of 5. And then we have the bottom beads is a value of 1. So it's 1, 2, 3, 4. This is 4. That's 4. This is 5. We put it together. This is 7. Don't forget to follow in for more abacus. Yeah, thank you, Audrey. Thank you for the reminder. So does that make sense, JJ and Micah and Alexandra? Right? So when we start doing it, and I hopefully Joseph is okay. Joseph, this is too easy for Joseph. He just came on board too. Thank you for the follow. Hey, Harley Happiness. Yeah, right? So what's going to happen is we need to understand how to read it. Well, this is 7. Why is it 7? This is 7 because I chose this to be my ones. Just as we write. When we write, we have our 10, ones, tens, 100, thousands, 10,000. So here is 7. This is 70. This is 700. How do I know? Because I'm using this as my ones place. If this is my ones, whoa, let me move this. If this is my ones, this is my hundreds. This is my thousands. So this would be 7,000. Do I sell these? I sell this one, yes, on my website. The link's in the bio. Take a look at my website. Hey, Anonymous. So, and then if we do this, this is 70,000. Does that make sense? So when we look at it, we're just looking at the number and wherever the column is, just as how we write. So here, this is what I wrote, and it's starting to scratch out, and I have to redo it. So it's 9,215. And then what's after here is my decimals. So it'd be like your decimals. So you have your ones, your decimal sits in the middle, right? It sits between the two columns. And then I have my tenths and I have my hundredths. And that's it. Oh, that's right. Does anybody have any questions? So what we can do is we can keep going. So we understand how to add, right? When we understand how to add, we can now subtract. What does that, what? Yeah. Because you know how to add, we know how to subtract. So the question would be, let's say 4. Let's say 8. We do 8. We do 8 minus 4. And that's what I did in the previous one, right? 8 minus 4. That's easy. Well, remember, we don't memorize our doubles. What we do is we understand our concept. We know how to do a 4. We know how to add a 4. All we got to do is we need to know how to minus a 4. Oh, yeah. And my book activities is my name. Thank you so much, Audrey. So here, I'm going to take away the 4. How do I take away the 4? I can't wait to teach my niece, nephew, and abacus once I get proficient. Oh, yeah. If I had a stock in abacus, I should be rich. Yeah. So here, how old is your niece and nephew, Alexandra? So here, this is adding. Now I want to subtract. I want to subtract it. So all I got to do is reverse the operation. I do 4 equals minus 5 plus 1. Plus 1. That's all I'm doing. So now I'm reversing my operation. So if I have my question 8, and I need to take away the 4. Well, wait a minute. We know how to add the 4. Now we can minus the 4. We're building on top of each other, right? We're building our concept. We're building our our thing. We're not adding more strategies. We're just building what we know. So if I'm going to minus the 5 and take away the 1. You're going to start seeing that there's a pattern. We want to add the 5 minus the 1. We want to minus the 5 plus the 1. This is the pattern. Hey, Colby, thank you for sharing my live. Good morning. Good morning. Good morning, everybody. I don't know, Joseph, you all right? Are we all right? And then May, hello, hello. And then Mal, I don't know if Mal's still here. Okay, I'm just calling out people's names now. All right, so that's what it is. So after we add the 4 and we take away the 4, my answer is 4. Does that make sense? So what we just did is we didn't memorize a strategy. We memorized a concept. And the concept is a critical thing. Thank you so much for the rose, Audrey. So this is 4. The answer is 4. We don't do doubles. We don't do minus 4. We don't do any of that stuff. What we do is memorize our concepts. These are core concepts. These are core information, right? Because we're already teaching the kids this. Well, let's take it a step further. Are there digital abacus like an app in movable pieces? Yes, there is. There is you just look up abacus. There's a bunch. Some of them kind of teaches you, but they don't go into in depth, which is fine. I think you have to pay money for it, and I haven't paid any money for it because I already know Abacus. But yeah, there's a few iPhone apps. There's a few JavaScript web sites that will have Abacus. Take a look at it. I would say Abacus. You could say JavaScript Abacus, and I'm sure you're going to get like a bunch of free Abacus. You can do a search for that. Hopefully that made sense. If you need help, give me a DM and I can send you some links. But yeah, there's a bunch out there. Do I have it on mine? No, not yet, because I'm trying to build worksheets. So these are the worksheets I'm trying to build. So and it takes time to build the worksheets because the questions are very specific. The questions are not like, here, have at it, because the way Abacus, the curriculum is, it's a very specific curriculum. Why? Because you have to build on top of each other. So like all of these questions are very math +5 based. So this book is +5. What does that mean? Well, in Abacus, we learn how to do simple first, which means there is no formula. That's what I talked to you guys about. I love the mazes. Oh, good. Kobe, that's funny. Okay. So simple means that I'm just moving the beads. I have 2 plus 2. I'm just moving the beads. That's what that means. Now the next thing is to know what the +5 friends or -5. We in the Abacus world call it friends. We call it small friends. We call it friends or whatever. Something like this, right? I call it making a 5 because I'm trying to make Abacus more mainstream. I'm trying to popularize Abacus. I'm trying to make Abacus public friendly. Kobe. Public friendly. I'm trying to teach people how to use it, and I'm trying to use math terminologies that everybody understands, like an add-in and substitution and isolate the variable. None of it public friendly. Yeah. Can you show the traditional book compared to your books? Yeah. So this is one of the books that I have. I was doing research and seeing like how do they do it. So this is what it is. That's what it is. And there's some of them. There's like 45 questions, but then I have this one, which is mine, and I make it a little bit more interactive. Oh, so this is the maze. This is another maze that I made. This is all about, and then this is find the hidden number. You find the answer, and then you try to find and then match the answer to the word. That's what that is. And then there's my maze. And then tic-tac-toe. I have a tic-tac-toe. And then, yeah. So this is my book. So I have a few books. I have 7 books. I'm still working on my other book. But yeah, it's interesting, like in the comparison. So there's another one. Oh, let's see. I mean, honestly, math can get really monotonous, right? So like this one, there's like 1, 2, 3, 4. There's 4 of them. There's 60 questions on one page. And this is not a very big book. 60 questions. And I'm like, that's really mind-numbing. So, anyways, is it as big? See, it's a little bit smaller. It's a little bit smaller, and they crammed in all those questions. So, anyways, yeah. Yeah, right? That's what I'm saying. Like it's not even fun. It's such a mind-numbing experience. And I'm like, I'm going to fall asleep. So that's why I was trying to make my stuff to be a little bit more interactive. Yeah, it's mind-numbing. Like I'm telling you. Ugh. Anyways, so I was just doing some. Those are the ones that we have. I mean, we're very, yeah. So I just started down this path of like trying to make it more interactive, and so I have this one, and then I have that one too. Yeah. I was wondering if there's Soroban history books. There is Soroban history books. If you, I don't know if you have a library, but you can go on the internet and you could look up Abacus, and everything I'm teaching you now is in the books. Go, you can read that too. There's a few out there. There's I don't know if you know that there's a Internet Archive. An Internet Archive, there's a few Abacus books there too, and they're all free. There's, if you just look up Abacus, the information's out there. I'm not teaching you anything different than what's in the Abacus world. Oh, so going back to here. So once you know how to do simple, then after that you know how to do the plus 5. After the plus 5, you need to understand how to minus the 10 and plus the 10. Some people call it family. Some people call it big family. Big friends. I'm sorry, big friends. I'm calling it making a 10. That's it. I'm making a 10. Why? Because what we're doing is we're understanding how to make a 10. We do 3 plus 7 is equal to 10. We know this concept. We know that 9 plus 1 is equal to 10. We teach this day in and day out. We do 8 plus 2 is equal to 10. And then there's the reverse, right? There's the reverse. And then the easiest one, 5 plus 5 is equal to 10. Now, why are we going to do this? Well, let's do a question. We do 8 plus 5. Okay? 8 plus 5. What do we do? How are we going to do it? Show me on the abacus. On the abacus, we have 8, and then we add the 5. Do we have enough beads to add the 5? Again, this is a conversation. This is a conversation that we have. We want to add the 8. No, we want to add the 5. We don't have enough beads to add the 5. So what do? We know the concept. We know 5 plus 5, but we're going to make it work. We're going to make it work for us. What does that mean? I'm going to isolate my variable. I'm going to move this over here. So I'm going to rewrite it. Say, when I add the 5, I want to plus the 10 minus the 5. That's what I'm going to do. Right? That's what I'm saying. So this right here is carry. Know your adds, your 5s and your minus 5s, your 10s and plus 10s. You will know how to do all of the adding and subtracting under the sun. It is scalable. Yeah, you're welcome, Alexandra. I'm so happy it clicked. It just clicked, right? It's an easy concept. It's so fascinating how simple it is. And yet we use all these math manipulatives to like try to get the kids to understand. We use a lot of math manipulatives. I have a few. I have like this one, the blocks. I don't know if you guys had blocks. I never had blocks when I was a kid. we were never blessed with blocks. I still had chalk on the chalkboard. We had a chalkboard for a reason, because it was chalk on a chalkboard. And I was old school. Mine was black chalkboard. Now there was green chalkboard. And then after the green chalkboard, there was whiteboards. And then after whiteboards, now you have like tablets and stuff. You have what do you call it? What do you call they call it the screen. I forget what it's called. Like a magical screen, right? Same, right? We did blackboard, then green board, and then white, like whiteboards. It's Abacus time. Yes, summer flip. It is Abacus time. We were just talking about the different stages of Abacus, the different phases of adding. Again, if we know how to add it, we will know how to subtract it. So let's say we did this one, right? Minus the 5, minus smart boards. That's what it is, smart boards. Yes, thank you. So again, we just need to subtract it. Minus the 5 is equal to minus the 10 plus the 5. Notice that my operations are now reversed. It's the same thing. So if I had 13 and I need to take away 5. This is the 5 I need to take away. I don't have enough. All I got to do is borrow. Old school people call it borrowing. New school people call it regrouping or trading. Abacus just calls it minus 10. That's it. That's all we're doing. We just call it minus 10. Minus the 10 plus the 5. That's it. So there's the different terminologies, but in Abacus we only call it. Oh my God, these are integer rules. Really? Tell me more, Jasmine, because I don't know. Honestly, I never took math. I only know abacus. I've been teaching abacus for 20 years. I've been I've been down this path to try to relate abacus to math now. Hey JP, I'm in the process of trying to connect everything that I know about abacus to what the mainstream math is. Really? Okay, integer rules. I will have to look that up. I make these notes. I watch Audrey's lives, positive and subtracting numbers. Yes. I've been trolling Audrey's lives and making sure whatever she says I try to listen in. And whatever terminology she uses I try to put it into mine. Integer rules. But all of this is like because I don't know any of this stuff. I don't know any of this stuff. Like I don't know the terminology. I just barely found out that this is a variable. It's funny. And then, I mean, I knew we were substituting. Like, I knew I was substituting. That was like a thing. But I didn't know what I was doing here was isolating the variable. And then Audrey was talking about a two-step equation. I'm like, oh my God, we do a thing called two-step equations. Let's break it down. Let's break it down. How do I do a two-step equation? Two-step equation just means that you're going to take this and you're going to put it into something else. That's all that is. But this something else needs to know if it's going to be an adding of a 5 or adding of a 10. So we can start that. The two-step equation. Colby, we're going to do two-step equation. What does that mean? Two-step equations. I don't even know how to say it in layman's terms. Let's do it. We're going to do one of the common ones is 6 4 7 7. We'll do 7 plus 7. Why is that? That's a double. No, it's not a double. It's a two-step equation. It gets a little complicated, but understand the concept first and then we will do it. There's also a double. Yes, we'll do that too. We'll do the 8 in a little bit. Let me do this one. You know what? Maybe that's the easier one. Let's do that one. Thank you, Ethan. We'll do 100 minus 8. Why are we okay? So the first thing we're going to do is we understand that minus 8 is equal to minus the 10 plus the 2. I just ordered 2 abacuses, abaci. Is that plural? Yeah, I don't know. I haven't figured that out either. It's either abaci or abacuses or abaci. I don't know. It is what it is. I ordered 2. Good. Cool. Okay. So this is the concept, right? We want to take away the 8. So we take away 8. My question starts with a 1. 100. Sorry, 100. I want to take away 8. I'm taking away the 8 here. This is the 8 I'm going to take away. But to take away the 8, there's no beads. This is a 0. So what do? I have this concept that I need to do. I need to minus the 10 plus the 2. I need to minus the 10 plus the 2. Minus the 10 plus the 2. I'm going to plus the 2 because I don't want to remember it. I'm going to plus the 2. Are we okay? We're going to plus the 2. I need to minus the 10. Cannot minus the 10. What do? Well, there's a concept. Minus the 10 is kind of the same as minus 1. Minus 1 is either minus 5, can't do it, or minus 10 plus 9. So what did I just do? I took this 10 and I expanded it to here. Is that what it is? Expanding? So I'm going to minus the 10 plus the 9. Minus the 10. I'm going to plus the 9. I'm going to minus the 10. I can. So it stops right here. That's all it does. That's all I'm doing. So I have 92. I don't know. Right? Expanded form. Oh my God. I'm making epiphanies. Expanded form. Like this is like crazy. This is crazy. So my answer is 92. We can take it a step further. We can say 4,000, right? Same thing. 4,000. Let's do 4,000. Maybe that's easier. Maybe these ones are easier because we only need to worry about the one thing. So we do 4,000. 1, 2, 3, 4. Right? 4,000. And then what? Minus what number? What are we going to take away? Take away one number, because then it's easy to show what I'm trying to say. Because if the numbers are too big, from 1 to 9, if the numbers are too big, then it gets confusing. So I just need another number. Give me another number. 5. Okay, good. 5. 5's easy. So I'm going to minus the 5. We're going to do it again. Okay, we'll do 3 next time. All right, minus the 5. Minus the 5 is equal to minus the 10 plus the 5. We know this. So if I want to take away the 5 here, I'm going to take away the 5 here. I'm going to add the 5 because I don't want to forget. I'm going to add the 5, but I need to take away the 10. Take away the 10. Cannot take away the 10. I already know this. What do? Minus the 10 is equal to minus the 10. Minus 1 is equal to minus the 10. Sorry, minus the 10 plus the 9. That's all we're doing. Minus the 10 plus the 9. Add the 9. Take away the 10. Can I do it? Minus the 10? No, do it again. Minus the 10. Take away the 9. Or add the 9. Minus the 10 plus the 9. That's it. That's all we did. So what is our answer? 3,995. 3,995. So we just did this repeatedly. Does that make sense? Oh, yeah. Right, JJ? Makes sense, right? These are, these are, the concept is simple. The numbers are simple, but the concept is fundamental, if that makes sense. Right? I mean, we could do it for all numbers, right? We could do it. Let's do another one. We could do it for as big as this. Let's do 50. Let's do 60. 1, 2, 3, 4. Same thing, right? We did this one. That made clocks in my head stop. So what's this one? Same thing. Take away the 3. Minus the 3 is equal to minus the 10 plus the 7. And then what are we going to do? Same thing. This is what we call what? Borrowing? This is a concept of borrowing, right? But instead of borrowing on paper, we're borrowing on the abacus. And I'm always playing around with my camera. That's not good. So let's go to 60. Let's do 60. 60. Where are we going? Come on. I'm just looking at my camera. Okay, so 60. 6, 0, 0, 0, 0, and then take away 3. Right? So what do? We take away the 3 is minus the 10 plus the 7. Minus the 10 plus the 7. I'm going to add the 7 because I don't want to forget it. So I'm going to add the 7. So I'm going to add the 7. I want to minus the 10. Minus the 10. What is it? Can't do it. What do? Minus 10 is very similar to minus the 1. Minus 10 is equal to plus minus the 10 plus the 1. Minus 1 is minus the 10 plus the 1. I'm sorry, minus the 10 plus the 9. Minus the 10 plus the 9. Minus the 10 plus the 9. Add the 9. Minus the 10. They can't do it. Do it again. Minus the 10 plus the 9. Minus the 10 plus the 9. I did the 9. I got to minus the 10. Can't do it. Minus the 10 plus the 9. So you repeat it until you get it. Repeat it until you get it. Why didn't you start from the left to right? Because I'm not taking away from here. That's why. How do I know I'm going to take, if I started here, how do I know I'm going to take away 3? I don't take away 3 from here. You take away 3 from wherever you're going to go. If the number here was 3, does that make sense? If the number was 3, you could go this way or you go that way. So if let's say we had 6,000, 1, 2, 3, right? And I had the 349, right? Then I would start from the 3 here. But I'm taking away the 1's place, so that's why I started there. Hey, Big Sasha, thank you for the follow. Does that make sense? So yeah, I would start here if I had more digits. That's why I start here. So we could do it. I mean, I don't know how complex this question is. We could do it. We could do 6,000, 1, 2, 3, 6,000, right? Take away 349. So let's do it, right? Take away 349. Excuse me. Take away 300, take away 3. So when we talk in Abacus, we don't say 300. We just know we're taking away the 3. We're taking away the 3 from this column. Can we take away 3? No. What do? We take away the 10 and we add the 7. Does that make sense? So what we're going to do is we're going to take away the 3 here. So to take away the 3, it's minus the 3 is equal to minus the 10 plus the 7. Oh, I already did that up there, but it's okay. I can reiterate it. So I'm going to take away the 7. I'm sorry, that's supposed to be 6. So I'm going to add the 7 because I don't want to forget, and I take away the 10. So now I need to do 4, right? Take away 4. When I take away 4, I have to take away 4 from the 0. So how do I take away 4? Minus the 4 is equal to minus the 10 plus the 6. I'm going to add the 6 so I don't forget. I'm going to add the 6. And then take away the 10. And then I have to minus the 9. Minus the 9, we know how to take away the 9. Minus the 9 is, same thing. Minus the 9 is equal to minus the 10 plus the 1. So I minus the 10 and plus the 1. So then my answer is 5, 6, 5, 1. Hey, one of the best! Welcome back! Welcome back to more math. Morning math! Well, actually, I guess it's afternoon math for some people. No wonder that kind of question confuses me. I always started from the left to right. Oh, yeah. Yeah. If it's a 1 digit, you stay with that one column. If it's 1 digit, you stay with the column. If it's multiple digits, then, then you do it. But, yeah. Yeah. So fun learning the abacus with you. Yes, thank you. Thank you. Whoop, whoop. Good morning, good morning. Good morning, good evening, good afternoon. Okay, great. Okay. Yeah. Anybody have any questions? I mean, we can continue on. But see, the thing is this is a plus 10 this is a making of a 10 formula. In Abacus world, we call it like big friends or whatever, right? But in mainstream math, we call it making of a 10. We're making a 10. We're knowing what the pairs of how to make a 10. We know 9 and 1 is a pair. We know 4 and 6 is a pair. Now we're utilizing it. We're making them work. There's no more freeloading. No more freeloading numbers. No more freeloading numbers. Anybody have any questions? Okay, so, right? It's so crazy. It's so crazy. Like, we do all these strategies and stuff. Like, this one. I know somebody would be like, well, why don't you just make this to 350, take away 350, and then take away the 1? You could. You could. I don't knock it. That means that, it's fine. It's not the abacus way. I'm just teaching the abacus way. You can move the numbers any way you want, right? I'm not saying that this is the end all. I'm just showing you a different way. That's all I'm doing, right? You could do this way, right? What is it? 6,000, right? Minus 350, and then you need to know you have to take away the 1. You could do it. I'm not knocking it. It's just another way. This is not the abacus way. That's why I don't teach it this way. I teach the abacus. So this is the way I'm doing it. Hey, Lofty! Right? Free-loading numbers. You like that? But everybody works in my world. Everybody works in my household. Anyways, so that's what it is. So yeah, somebody mentions like, yeah, you could do that. But it's not abacus. Like there's no pair that says 350 plus 1. But there is a pair that says 4 plus 6. And so what we do is we build this concept. We build and build and build on the same concept, and we just build it till we get it and we understand it. Yeah. So we can do another one. Oh yeah. So let's do this one. I was starting off with this one. This one is more. I like Ethan. I really like this one. This question. This was a really good question. I'm going to put that back into my tool belt. This one makes me might be a little bit more complicated. Why? Because now we're mixing in. Hi, give Lynette some love and tap the screen. Thank you so much, Audrey. Okay, so this is a little bit more complicated. Why? Because now what we're dealing with a 10 and a 5. Now we're mixing the two. What does that mean? Well, we have 7. I want to add another 7. We know that adding a 7 is equal to plus the 10 minus the 3. So we plus the 10, but can we take away the 3? No, we can't take away the 3. So what are we going to do? Well, minus the 3 is a 5 concept. I think this one's a little more complicated. I do like Ethan's better. So we minus the 3. To minus the 3, can I take away the 5? Yes. To take away the 5 is minus the 5 is equal to plus the 2. So I minus the 5 and I plus the 2. So then my answer is 14. Make sense? Okay. Do we want to do some bead recognition? We can do some bead recognition. I gotta look it up. I gotta look up my little maze. Oh, nuts. I didn't set it up. I didn't set it up. Maybe I'll do it next time. You know what? I'll do it next time. I'll have to set it up next time. I'm intrigued. Anakin is gone. Aww. Oh, good. But you're intrigued, Anakin. So let's review. Can you think of random numbers and make questions instead of finding right numbers to add? Before I do that, Ethan, I can do any numbers. The problem is it depends on the class. I don't want to confuse the class. So you can do any numbers. It just depends on how complicated it can get. So Anakin is gone is how to count. No, not how to count, how to read the abacus. 1, 2, 3, 4. This is 4, and then this is 5. Because this is 5, okay, Jasmine, I'll see you later. Great, I'll catch you too. So this is 5, we have 6. 5, 6, 7, 8, 9. Notice the 5 and a 4 is 9. Together is 9. Each column has 9. This is 9, that's 9, this is 9. They're all 9s no matter what. So how do you do 10? 10, well, if this is 1, this is 10. If this is 10, this is 100. Does that make sense? Anakin is gone. I'm trying to find my... I always just throw away my stuff, and I just need to know. Here it is. Here it is. Yeah. So, when I'm looking at it, we have ones, tens, hundreds, thousands, 10,000. So when I was talking about it, it was 1, 100. I'm sorry, 10, 100, 1,000, 10,000. So we just pay attention to the columns. Why am I starting here? I'm starting here because this is my decimal. Not my decimal. This is my dot indicator. It tells me that this is the ones place. It just labels it for me. My ones, my tens, my hundreds, my thousands, my 10,000. We can do this one. This could be my ones, and then this would just be 10. Or this is my ones, and then this is my 10,000. Does that make sense? Anakin is gone. So I just want to keep everybody up to speed. All right. So people come. Interesting. Yes, it does. Okay, good. So when I compare it, let's do this number. So this number is 9, 2, 1, 5. Glad you're reviewing it. So I was confused. Oh, Ruben, you should have told me. If you don't comment, the squeaky wheel gets the oil. You gotta let me know. If you don't know, I don't know you know. I don't know what you know. Tell me, please. Let me know. If you don't understand, we gotta go back and we gotta regroup. Let's regroup. Like math. No, we're not regrouping. We're gonna do minus the 10. Like, I don't know. I'm trying to figure that one out. All right. So again, we're going to do 1, 2, 3, 4. All the beads of the bottom has a value of 4. The horizontal bar is what tracks us, like our phones. Our phones are what tracks us. The horizontal bar tracks us. If Siri and Alexa and what? Hey Google, they all track us. That's what the horizontal bar does. The horizontal bar tracks us like GPS. So we have 4 and then we have 5. 5, 6, 7, 8, 9. After 9 we have 10. How do I know? Because it looks like 1, but in a different place value. That's all. These are place values. Every column is a place value. Every column is a digit. Every column is a specific digit. So this is 1, this is 0. If I did this, this would be 9. 910. Make sense? Anybody have questions? Let me know. We can keep doing this. I've been counting on the abacus for 20 plus years. Another hour would not be wrong, would not hurt. All right. So so then the next thing we're going to do is we're going to know how to add. Oh, you know what? Here's a question. Let me know in the chat what number you think this is. If I did this, I did this, I did this, and I did that. What number is that? I'm going to move this because I get confused. I get confused easily. All right. What number do you think this is? Ethan says 397.1. Yes, exactly. That's what it is. Because we have to remember. Thank you, Allie. Yes, 397.1. Cool. So let's do another one. Are we ready for another one? We do this one and then this one. No, this one. There we go. There we go. There we go. I'm done. I'm done. What number is this? Hey, JJ. What number is this? $88 1982. Yes. Yes. Thank you, JJ. Thank you, Allie. Make sense? So that's about reading the abacus. So the next thing we can do after we read the abacus, we can start understanding how to move the beads. So when we're moving the beads, we already know how the beginning of the moving of the beads. What does that mean? Well, we move the beads, we add the 5, and we add 2, we get 7. So moving the beads, we start off with, do we have enough beads to add? And we sure do. So even if I had this one, right? 687. Do I have enough beads to go 100? Yeah, I just add the 1. That's it. I'm only adding 100, right? 110, 112, 112, 112. This is so much easy. This makes so much sense now, and it seems like it's a really fun way to do math. Yes, yes, I do too. I think it's really cool, and that's why I also created some worksheets. I created worksheets that are very specific to Abacus, because there's no worksheets that is specific to Abacus. There's some really boring ones, but they're not interactive like mine. So, but yeah, and then what I have is there's a few activities. This is like color by number, but the actual moving of the beads is kind of cool too. So in Abacus, what we do is we focus in on the add-in. We focus in on the add-in. We do not focus on the result. So when we're looking at it, we do 1, we add the 1, and then we add 7. How do we add 7? 5, 6, 7. We add 7. That's what we do. That's all we're doing. We're adding 7. So our answer is now 8. Let's do another one. We do 5, and was a 3. I think it was a 3. So notice what I'm doing is I'm going back to figuring out what my add-in are. The reason why is because we want to make sure we understand how to add the add-in. So here we don't focus on the result. So if I did another 8, right? But I don't do 8. What I do is I do 5 plus 3. And there's 8. Okay. Well, what happens if there's not enough beads? Well, if there's not enough beads, then we start using formulas. to use the formulas, we understand that we have these things called concepts. We have core concepts that we're teaching. We're teaching children these core concepts, and that's all. That's it. We drop the ball after the core concept. What does that mean? Well, it means that we add them, right? We tell them these concepts. Let me go back because I wrote it really nice. I'm trying to be cognizant, Audrey, of like how I'm writing, so that when I write my notes, I can try to look at them. So this is a core concept that we're teaching the kids. 4 plus 1 is equal to 5. And then we do the inverse. 1 plus 4 is equal to 5. And then the other one is 3 plus 2 and then 2 plus 3. John J. Hippie. That's a really cool name. So after this is the core concept that we're teaching. That's it. That's what we're teaching kids in school. However, Abacus makes our numbers work. So what we do is we isolate the variable. Okay, that's too much. Okay, let me isolate the variable. So when we isolate the variable, yeah, I've almost got it to a point where I can rewrite this. How long have I been doing math this way? I've been teaching this math for 20 plus years now. But I'm pretty old though. So I actually learned Abacus when I was like my early 30s. And then I was like, this is crazy. Why are we learning this? It's because my dad wanted to start a business and he just dragged me into it. So I learned how to read the abacus. I learned how to use the abacus. My brother and I learned how to use the abacus, and that was about 20 years ago. Yes. Thank you, JJ. And so my boys, I have 3 boys. They all know how to use the abacus. Can they teach you? No, not like me. But they know how to use the abacus. You give them an abacus, they can do it. Do they have strong number sense? Yeah, they have strong number sense. Do they do abacus competition? No. I didn't push them to do abacus competition because I don't see a point in it. I just wanted them to be comfortable with abacus. I just wanted them to be comfortable with numbers. And so I wanted to make sure that they had a strong sense. So we're going back to the 4. So we do 4 plus 1 is equal to 5, right? And then the inverse is 1 plus 4 is equal to 5. And then there's the other one, the other pairs, which is 2 plus 3 is equal to 5. And then 2, I said it again, but you know what I mean, right? So the first thing we're going to do, hey, Andrew knows! Andrew, you know. Do you join the competitions? No, I don't join the competitions. I don't join. But I don't. They're not anywhere around here in California, and I don't want to travel. I don't want to travel for You know what? I take that back. I don't want to travel for math competitions, for abacus competitions, because it's a little stressful. I would rather travel for marathons. Like I run. I love running. So I would rather travel for running. I went to San Francisco to go run. I'd do that. I'd do the New York Marathon if I ever got accepted, right? I'd like to do something like that, but I don't do it. How do kids do finger abacus? I don't know. I don't do finger abacus. I do abacus. Oh, so what are we doing is we're isolating the variable. To isolate the variable just means that we're going to take this 4 and we're going to make it utilize. So it's a 4, right? And then if you notice, if I do this, a 5, they don't equal to each other. So to make it balance, we have to balance this equation. We have to do minus 1. I heard in abacus competition, all pupils get trophy. I'm sure there's participation trophies too. So why are we doing this? Because the question is, where's my... trying to find my question. Oh, here it is. So we did an 8, but the problem is we don't know how to add another 8. What are we going to do? So the question is this. So here's a bunch of questions that really relies on each other. So trophy for those that knows how to do the abacus. Yeah, okay. We have 4. We want to add the 4. So we add 4 on the abacus. We add another 4. Well, we can't add another 4 because there's no more beads. There's no more beads to add the 4. So what do? We have to plus the 5. This is the concept, right? We started from here. Now we're making it work. We started from here. We're making it work. We want to add the 4. Add the 4 is plus the 5. Take away the 1. And my answer is 8. We don't memorize doubles. In abacus, we don't memorize doubles. What we memorize is the concepts. We memorize how do we utilize our numbers. So the second one, right, we do this one, right? 3 plus 4, same thing. We don't we don't do the strategy doubles minus 1. What we do is we do 3, and then I want to add the 4. I need to add the 4. I need to plus the 5 minus the 1. Does that make sense? Anakin is gone. Does that make sense? JJ, you all right? So I think we were like, this is review. Yeah, this is review. So this is just about how to add a 5. How to add a 5. So, and then it breaks it down. So we have 8. Or 7. We have 7. So, and then, because we know, you know what? Because we know how to add a 4, we know how to minus a 4. So let's do another one. Let's do 17 minus 4. So the question is 17 minus 4. Wait a minute. That's too big. No, it's fine. It's fine. You know why? Because we know this concept. We know this concept. So we have 17. So we're going to add 17. Add 17. And then what are we going to do? Well, we need to minus the 4. We know the concept. We know this. We're going to build on this. What we now do is we do the inverse. The inverse of adding the 4 is minus the 4. We have to do something with the 5. We added the 5 here. We have to minus the 5 here. We minus the 1. Now we have to add the 1. So then we just do it in reverse. We minus the 5 and then plus the 1. And our answer is 13. I don't know if you saw that. Hopefully you guys saw that. Let me do it again. So I have 17. I want to take away 4. To take away 4, I have to minus the 5 plus the 1. So I minus the 5 and I plus the 1. So then my answer is 13. And I always play around with my camera. I always get it just right, and then all of a sudden something happens, like the sun starts shining, and then all of my exposure gets blown out. So now we know this, right? And it's the same thing with this one. Hey, Barbara! Oh, thank you. Let me know if you have any questions. Maybe the camera is unfocused. No, it's because the lighting. Because it's the light. The sun comes in, the sun comes out. It all depends. And then it shines it shines on my paper. So, anyways. Yeah, Barbara. Barbara, do you have any questions? Wow, thank you guys for the likes. 10 people are still in the room. Woo! Okay. We can continue on. So this is about understanding the 5. The next thing we're going to do is we're going to understand, if we understand how to add the 5, we can take away the 5. That's not a problem. Now let's do the next one. Let's do take away the 10. Let's do adding a 10. We're going to add the 10. Well, what do we know? We know how to make a 10. Why are we going to make a 10? We're going to make a 10 because we're going to utilize this concept of this 10. This 10 is what we talk about: grouping, regrouping, trading, carrying over, and borrowing. Yeah, there's a lot of numbers for that. So we have the first number I'd probably do. I like colors. Do we do 9? So we do 9. 9 plus 1 is equal to 10. What's next? 8 plus 2 is equal to 10. We have 7 plus 3 is equal to 10. 4 plus 6 is equal to 10. I do both ways. Thank you, Ethan. And then the last one is 5 plus 5 is equal to 10. These are the only things that we need to know. Why? Because we need to know that these are pairs. 9 and 1, 8 and 2, 7 and 3, 4, 6, 5 and 5. We need to know this. Hello, Olga. Thank you so much for liking the live. So we need to understand this. And again, what happens? Well, we know how to isolate the variable. So if we know how to isolate this 4, we're going to isolate this 9. And that's where we start talking about the 9s. So if we do the 9 plus the 9 is equal to plus the 10 minus 1. And then again, it's the same way. Even if I want to do it the other way, if I want to plus the 1, it's equal to plus the 10 minus the 9. Do you see how they're pairs? So this is building blocks. We're building on each other. We're building that these two are pairs. And it becomes very critical when we start doing some adding and subtracting, when we start doing carrying over, because then we start going into understanding how to do a minus. So one of the questions that Ethan gave us, which was a really good question, was, what was it? Was 100? 100 take away 8. We do, you know what? We do 99 plus 8. Let's do 99 plus 8. So I add 99. I want to add the 8. There's not enough to add the 8. What do? I need to plus the 10 minus the 2. So that's how I add the 8. So if I want to add the 8, I want to plus the 10 minus the 2. So I'm going to plus the 10 minus the 2. Well, I'm going to take away the 2 first, because that's what I remember. And I need to plus the 10. There's not enough beads to plus the 10. I know this. I can plus the 1, plus the 10, minus the 9. Thank you, Anakin is gone, for the follow. Plus the 10 minus the 9. Plus the 10, take away the 9. This is a very fundamental. It's one of the pillars. So my answer is 107. Yep, that's what my answer is. 107. 107. Yeah. Hey, Grandmother Willows. Make sense? So before I forget, I'm going to continue to count. There's a few people that came in. So before I go on, I can count. 1, 2, 3, 4. I can read the abacus, actually. I'm reading the abacus. I'm not counting. I'm reading the abacus. So 4. This is 4. Every time the horizontal bar is touching, every time the beads are touching the horizontal bar, this is 4. This is 4. This is 5. So 5, 6, 7, 8, 9. Notice I have 5 plus 4. 5 plus 4 is 9. Because this is 9, this is also 9. Now, if we do 10, we know what 10 looks like. This is 1, but if we move it one column over, this is also 1, but this is 10. How do I know? Because I have my 1s, my 10s, my 100s, my 1000s, and my 10,000. So if I line it up, these are place values. 1s, 10s, 100s, 1000s, 10,000. Make sense? We do 510, 514, 524. It's all about reading the abacus. When we read the abacus, we're done. We understand it. And that's what it is. This stuff right here, this is a method, but we're not doing these calculations. These are all in our head, right? We're just moving the beads. If I need to add the 10, if I need to add 6, I need to add 6 to this number, to 524. I need to add the 6. What do? Plus the 6 is plus the 10 minus the 4. I plus the 10 and I take away the 4. But see, I just move the beads. I say it out loud, but that's what I do. So my answer is 530. And that's it. Do we have any other questions? Do we have questions? Do you guys want to keep going? We can keep going with questions. Let's see. Here, let's do another. Let's do some minus. Let's do some minus because I don't do enough minus. There's not enough takeaway in my life. All right, we're going to do 16. 16 take away 2. 16 take away 2. Now, this is just a random number, right? But we have to critically think about it. This is what critical thinking is. This is how abacus provides critical thinking to children, right? To whoever's doing abacus, it provides critical thinking. So I have 16. Now the question is minus the 2. The problem, right? The math question is minus the 2. My question is, can I take away the 2? I cannot take away the 2. How can I do it? How can I take away the 2? I can utilize the 5. If I can utilize the 5, do we remember how to take away the 2? trying to find my little flippy thingy. Didn't do that. Where is it? So I want to... Oh, I didn't do it. Okay. So I want to take away the 2. If I take away the 2, I know I have to minus the 5 plus the 3. So if you look, if I use this as my indicator, right, I have to minus the 5, and I add the 3, and then I add the 3. So my answer is 14. Hey, Mike Johnson. Dish 72. Woo! Hold, please. That's it. So I like this because then it reminds us what we're trying to do. Plus the 5, minus the 5, plus the 3. And then when I take it away, we get 16. Because what we're doing is we're focusing on the column. So when we had it, it was like that, 16. And then what we need to do is we need to take away 2. I would love to stay, but I need to sleep. Oh, yeah, Ethan, go to sleep. Midnight math for you. No more midnight math. Have a good night. I will see you in my next live. So, does anybody have any questions? Other than that, I mean, it is what it is. Yeah. Good night, Ethan. Okay, so, that's the answer is 14. 14. Where do I live? When am I live? I am live often. I'm live morning math, afternoon, abacus, learning lunch. I don't do evenings so much because that's usually when I have dinner. But then there's midnight math. Yeah. I'm trying to compete with Audrey. Audrey goes live pretty often, so I'm trying to be like, if Audrey's on, I'm gonna do it. She inspires me to go on live, so I'm on live pretty often. 10s and the 1s, I'm a little confused. Oh, okay. So the first thing we're gonna do is we're gonna understand. Do we understand this part? How to make a 5? Ruben? Do we know how to make this 5? Sometimes it takes a little bit of time. And then all of a sudden it just go, okay. So, okay. I got it. I think I got it. Okay. So the difference between this, right? Why? Because we need to start having a process when we do things. We have to have a process like who comes first, what comes second, kind of a thing, right? So the first thing we're going to do is we're going to understand that with the 5s, we can either the 2, adding the 2 has 2 sets of equations. There's a plus 5 minus 3, or there is a plus 10 minus 8. Now, which one do I use? You want to use the right one. You want to be Goldilocks, right? You want to use the right one. You don't want to go overkill, like what? The wolf and the brick. Anyways, I'm trying to think of the 3 little pigs, because he huffed and he's puffed, right? So the thing is trying to make sure you use the right one. But these are questions we need to have. So one of the questions is, when do I use the 2? When do I use this? I use it because my first thing to do is when I have 16, the question starts with, if I want to take away 2, can I take away the 2? That's the question. Can I take away the 2? No, I don't have enough beads. So what's the next question? Can I take away the 5? That's the next question. It will always be the next question, no matter what. When you're doing anything from 1 to 4, because the 5, anytime we're doing this, we always need to know, can we do the 5 first? That's it. That's all we're doing. We're just stripping out all the complexities. Those are the 2 questions you have these are the 2 questions I have in my head. Can I take away the 5? Yes. So then it stops there. I just need to do this one. So if I'm going to do the 2, then all I got to do is plus the 5 minus the 3. So I'm going to plus the 5. No, I'm sorry. I'm going to minus the 2. I'm minusing the 2. I'm so sorry. I need to minus the 2. I need to find here it is. Minus the 2. I'm taking away the 2, so I minus the 2. Can I take away the 5? Yes, I can take away the 5. To take away the 5 is minus the 5 and then plus the 3. Did that make sense, Ruben? Is that the confusion you were is that where you were confused? Oh, I get it. Oh, okay. Yeah. So, you see, that's the thing. Like sometimes I forget to say that there's a framework. The first thing to do is always ask if you have enough. If not, then can you use the 5? So here, let's do this. My question is, 14 take away 1. No, this is all. We all have enough, right? 14 take away 1. 14 take away 2. Okay, no, never mind. Let's do this one. 15. 15 take away 2. 15 take away 2. Can we do it? No, we cannot take away 2. So what do? Can I take away 5? Yes. You know what? We could say, can I take away 10? You can. You can take away 10. Let's do it. Take away the 10 plus the 8. How do you plus the 8? Well, plus the 8, still here. Now you're just going roundabout. I want to plus the 8. I need to plus the 10, take away the 2. I still need to take away the 2. Can't do it. See how you're just going in circles. So you got to do the one that's the next one out. You got to do what is next. So if I have 15, I need to take away the 2. To minus the 2, can I take away the 5? Yes, I can take away the 5. That's the next step. Always the next step. So minus the 5 is take away the 5 and then plus the 3. So these are the formulas that we need to know. When you understand the formulas, then you can go further. You can go to do the plus 10s and the minus 10s. Yeah, you're welcome. You're welcome, Ruben. Let me know if you have any more questions. Okay, but, oh, Joseph, you're still here. Joseph, do you have any questions? Thank you guys for joining. Thank you guys for the likes. Oh, wow, I got 10,000 likes. Pretty amazing. Okay. Anybody have any questions? We can keep going. I mean, there's a bunch of math questions, but then it gets to a point where it's like, oh, okay, I'm going to go get some breakfast, actually. It's been a while. It's been a little bit. So, anybody have any questions? If not, I am gonna sign off. I think it's time to head on out. But I do appreciate everybody joining. Let me know if you have any questions, and I'll be on live again. I do enjoy this. No, wait, 621. 621. 621. That's what it is. Thank you, Barbara. I hope it made sense. Let me know if you have any questions, and any questions of any of the activities that I have. I'm trying to abacify everything. So there's more worksheets to come. I just got to get them out the door. All right. Thank you. Thank you guys for joining. Thank you, everybody. And I'll see you on my next live. Bye. This was awesome. She also has a YouTube channel. Oh, I can't wait for your next live. Yes, thank you, Audrey. I do have a YouTube channel. Okay, I'll see you in the next live, Ruben.